So now we are going to discuss about measuring what we call the length in units and measurements. Length measuring. Length measuring. Length measuring. So in length measuring, 1 meter is equal to 100 centimeter. 1 centimeter is equal to 10 millimeter. So that is equal to into 10 can multiply 1000 millimeter. So 1000 millimeter mm. 1 meter is equal to 100 centimeter. So now that is equal to 1000 millimeter. Now we need generally this length measuring. 1 centimeter is equal to dash meter. Now people are going to say 1 by 100 meter. So otherwise they can say 1 by 10 square meter. Otherwise 0.01 meter. For and all, this is the best value is 10 to the power of minus 2 meter. 10 to the power of minus 2 meter. Conversions are very easy to do it. Understanding? Next. So 1 centimeter is equal to this much you got. Now I can go to write 1 millimeter is equal to dash meter. Dash meter. So literally you can write what you want to say. You can write it as like this. You can write that is equal to 1 by 1000 meter, or you can say that is equal to 0.001 meter. Then simply I will write 10 to the power of minus 3 meter. So 1 millimeter is equal to 10 to the power of minus 3 meter. So that is equal to 1 by 10 cube meter, 1 by 10 cube meter. Okay. So that is equal to 1 by 10 cube. So that is equal to write as 10 to the power of minus 3. So the best way is, this is the best to calculation purpose. So exponential form is the best one. Now this is the 1 millimeter is equal to 10 to the power minus 3 meter. 1 centimeter in terms of meter is 10 to the power minus 2 meter. So this is what next. 1 kilometer is equal to 1000 meter. 1000 meter. That is equal to 10 to the power of 3 meter. Or in terms of centimeter, 1 meter is equal to how many centimeter? 10 square centimeter. So that is 10 to the power of 5 meter. 5, what you got to say? 5 centimeter. 10 to the power of 5 centimeter. So why because? So 1 meter is equal to 10 square centimeter. Okay, if you want it in millimeter, 1 kilometer is equal to how many millimeter? So 10 to the power of 6 millimeter. 10 to the power of 6 millimeter. So reverse conversion you can take. So 1 meter is equal to 10 to the power of minus 3 kilometer. So 1 millimeter is equal to 10 to the power of minus 6 kilometer. So these conversions are very important. Okay. So this is the 1 kilometer. So 1 centimeter is equal to 10 to the power of minus 5 meter. So that is called length to measure. All of you understood? Now go to the area measuring. Area. So in area measuring, area measuring. 1 centimeter square is equal to dash meter square. So already we know that 1 centimeter is equal to how many meter? 10 to the power of minus 2 meter. So 1 centimeter is nothing but centimeter, that is 10 to the power of minus, what you call 10 to the power of minus 2 whole square, minus 2 meter whole square. That is equal to 10 to the power of minus 4 meter square. So 1 centimeter square is equal to this much. So centimeter square can be written as what? Centimeter is equal to the power of minus 2 meter whole square. That is, so that will give you this much square. So now 1 millimeter square is equal to dash meter square. So 1 millimeter is equal to 10 to the power of minus 3 meter whole square. So that gives you 10 to the power of minus 6 meter square. So 1 mm square value. So they are going to give the area in centimeter square, the Newton per centimeter square supposed to be. I am going to give example. So the stress value, they are given a stress or pressure value. So suppose to be 10 Newton per centimeter square is given. So multi-system of units is wrong. So you have to make single system. So now single unit system. This is a centimeter in CGS. If it is an SS system, then what you can write? So that is nothing but this is totally wrong. So 10 Newton. Then what you do? Centimeter square you have to write in meter square. 10 to the power of minus 4 meter square. Now that is equal to, we go to the numerator, 10 to the power of, what you call it, 5 Newton per meter square. Now this is correct. So that's why we need it in the conversions. So area is over. Now volume measuring. Volume measuring. Volume measuring. Now write volume measuring. Volume measuring. So write volume measuring. Volume measuring. Volume measuring. Volume. Right. Volume measuring. Volume measuring. So 1 centimeter cube is equal to dash meter. So 10 to the power of minus 2, 1 centimeter is equal to what? 10 to the power of minus 2 meter. 10 to the power of minus 2 meter whole cube. So that is equal to 10 to the power of minus 6 meter cube. So you write minus 6. Next, 1 mm square, sorry, 1 mm cube is equal to dash meter. But 1 mm is equal to 10 to the power of minus 3 meter. So that we write cube. That gives you 10 to the power of, a to the power of 10, 4 to the power of minus 9 meter. So 10 to the power of minus 9 meter. You got a volume meter. Okay, sir. And one more most important is 1 liter. No. Okay, 1 liter of H2O at 4 degrees centigrade gives you 1 liter volume is equal to 1 kg. 1 kg. So this is also volume in terms of mass. It's to water. So this is very, very important in gases, expansion of gases. Okay, right. Next, mass measuring. Next, mass measuring. Mass measuring. Mass measuring. Now, 1 kg, 1 kilogram, 1 kg is equal to 1000 gram. So 1 gram is equal to 1 by 1000 kg. So that is nothing but 10 to the power of minus 3 is the best. So for 1 gram is equal to, so power notation is the best. So calculating purpose object to it is used for. You can write 0.001 also. This is the mass measuring. Next, 1 quintal. 1 quintal. 1 quintal. 1 quintal is equal to 100 kg. Generally, you are going to write by buying the rice. 1 quintal is 1 ton. 1 ton is equal to 1000 for calculating purpose. This is called mass measuring. Right, all of it right. Next, time measuring. So time measuring. You write time measuring. Time measuring. Right, all of it. Time measuring. So in time measuring, all of you know the time. 1 hour, 1 hour, which we are hour. We short for HR. 1 hour is equal to 60 minutes. 1 minute is equal to 1 minute is equal to 60 seconds. So therefore, 1 hour is equal to 60 into 60. How much are 60 into 60 seconds? That is 1 hour is equal to 3600 seconds. Now, 1 day is equal to 24 hours. Now that is equal to 86,400 seconds. Now you have to multiply 24 into 24 to 3600. You can get this many seconds. 1 day is equal to this many seconds. Right. This is the now. 1 shake, most important. 1 shake. 1 shake. 1 shake is equal to 10 to the power of minus 8 seconds. 1 shake is equal to 10 to the power of 8 minus 8 seconds. 1 shake is equal to 10 to the power of minus 8, 10 to the power of, right sir, 10 to the power of minus 8 second. No problem. So this is the time measuring. No. So derived physical quantities. Derived physical quantities. Right, definition. The physical quantities which are derived from fundamental quantities are called derived quantities. Fundamental quantities are called derived quantities. Or the physical quantities which depends upon fundamental quantities are called derived quantities. Another definition: multiple or submultiple of multiple or submultiple multiple or submultiple of fundamental quantities are called derived physical quantities. There are n number of derived quantities. There are n number of derived quantities. Oh, we'll stop. No. So derived quantities may be scalar, comma, or vector, scalar or vector, or tensor, 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 scalar, comma, vector or tensor. Okay, scalar or vector or tensor. Right, sir. Now write examples. Just a few examples. So dependent quantities are called derived quantities. Example, take examples. Few examples. What do you call it? Area, volume, density, speed, velocity, acceleration, force, etc. Many other. Okay. So if you know, generally speaking, if you know velocity, area, velocity, acceleration and force. If you know velocity, acceleration, force. So maximum derived quantity can be derived in physics. So maximum these people all are depending upon this only. You know, velocity, acceleration and force. So many you are getting easily. Okay, right? Now we'll start with the what you call to say first one, area. So area, basic formula area is equal to length into breadth. So the dimension formula of length is, all of you know, L only symbol. Breadth also L only. So if you multiply, you are going to get L square. So what about the mass? Without mass, no length. You want to measure also time required. That mass is unit mass. You can write it as m to the power of 0, L square t to the power of 0. Anything to the power of 0 is unit. So this is called dimensional formula, right? Dimensional formula. Area. Okay. Now you are writing unit. So units. So unit writing. Unit. What is the unit you can write? In serious system, centimeter square. We called as serious. In MK system, meter square. In FPS system, FP square area. So we call FPS system. But you are not using, but still there is a, but in generally you are using in what you call some places sports you are using and some places you are using and height measuring. Okay. So this is the what is SI system also? Area is same meters per hour. Generally SI system is used for site distance. So CDS system, MKS system, APS system. The full name of CDS is what? Centimeter gram second. Okay. MKS full name is meter kilogram second. APS system is foot pound second. SI system is system international or international standard system. International standard system. Okay. Now you try next one. All of you complete it up. Next go try volume. Next you have to try volume. Volume. So volume. What is the basic formula of volume? Length into breadth into height. LBH. General form. Length is L. Breadth also L. Height is what you call height also L only. So if you use L cube, unit mass, unit time. You call it DMF, like short form, DMF of volume. So write unit centimeter cube or cubic centimeter. You call it CGS and meter cube, MKS and FT cube in FPS system. Now write density. Density symbol is D or rho. So this is called density. So density is equal to mass by volume. All of you know density is equal to mass by volume. So mass is M, volume is L cube. So now we can write it as DMF of density rho is equal to M L to the power of minus 3. What the time? Unit time. Mass power is 1. Now you are going to write unit. Right? Like all of you write unit. So what is the unit of this one? Unit. Unit. In serious system, gram per centimeter cube or gram centimeter to the power minus 3. We call it CGS. In MK system, kg per meter cube. MKS or SI or SI unit also. The AP system, LB pounder per FT cube. But FPS system. Okay. Now here already we said 1 pound. 1 pound. The symbol is LB. Is not kg. That is called 453.6 gram. 1 pound is how much? This one. 1 foot is equal to 30.46 centimeter. 30.46 centimeter. Okay, this you have to remember first. Now, density over. Next you write speed. Speed. So write speed. So speed is equal to distance by time. Distance by time. So distance is L, time is T. Therefore L to the power of minus 1. What is the mass? Unit mass. So we got DMF of speed. So unit. You write unit comfortably, you write easy to write. So centimeter second raised to minus 1 or centimeter per second is called CGS system. So in MK system, meter second raised to minus 1 or meter per second, MK system. So no need of FPS. So SS system also. SS is generally scientist names. And right, it is a scalar node. Speed is a scalar quantity. Scalar quantity. Okay, right? Velocity. Inside velocity. What is the velocity? Displacement by time. Velocity. So velocity V is equal to displacement by time. Displacement by time. So displacement is L time t. You can say L to the power of minus 1. What is the mass? Is unit mass. So this is called BMR. So velocity. So then we can write unit. What do you write? You write also same thing. Centimeter second inverse or centimeter per second. We called CGS. Okay. Next. MK system, meter second inverse or meter per second. We call MK. So definition, what is the difference? The rate of change of displacement is called velocity. Now the rate of change of distance is called speed. So the rate of change of distance is called speed. So in the denominator time means in the denominator time you can say rate. So it is called rate of change of displacement. It is a displacement is a vector quantity. So it is a vector. So it is a vector. One velocity is a vector. So how you got this one vector? We are going to say velocity is a vector. Now see here. Now I can draw the small diagram. Now point A to point B you want to move. So what is the first straight one? This is called displacement. Shortest path is called displacement. And this longest path is called distance. We call distance. Or understanding that? So displacement is a vector quantity. Distance is a scalar quantity. Distance never becomes zero. Never becomes zero. Okay, zero and negative. Displacement will become zero and negative also. Become zero and negative, but distance never becomes zero. So displacement less than or equal to distance. Okay. Never becomes greater. Less than or equal to distance. So this is the most important. And displacement becomes zero, negative, whereas distance never becomes zero or negative. Distance never becomes what you call zero or negative. So displacement becomes zero and negative. Okay, or negative, right? This point you have to remember. Okay, now all of you, right? So displacement is less than or equal to distance, magnitude wise. Okay, sir. Next. Okay. Right. Velocity distance, this is what you call speed is over, now we discuss it.